Hello everyone, odedex here, welcome to episode 161 of my Sin2 Let's Play. So in the previous episode, I started automating the process of auto-crafting build-craft gates. And as you can see at the moment there is an operation running because I've actually requested my system to craft a bunch of end gates. So as you can see they're all being crafted at the moment by this assembly table. I've actually requested, specifically I think I requested like 34 gates. Or I know some large number, not sure 100%, but some large number. Anyway, as you can see, it's being processed, and because it's not that fast, there are gonna be multiple changes. Now, originally I said that I have two major features that I want to do. The first one I pretty much completed in the previous episode, which was to fully automate the process of auto-crafting gates through applied logistics. And the second feature would be to fully automate the process of making those engines run. Like making sure they run, they don't explode, and they also don't create too much energy when it's unnecessary. Now for the second feature, which is what I've just said, I actually need all those gates, I'm gonna need gates anyway. So before I get to that, I actually have a couple of other things I can do anyway, since I'm waiting for this to finish. So the first thing I want to do is actually I realized that at the moment the ice shards that I'm harvesting are creating through an icy queen. But I'm actually quite silly because an icy queen can mutate even further into I think a glacial queen or something, which has even higher percentage rate of creating those ice shards. So as you can see, I've got all the icy bees that I've got through my inoculator. All of them are inoculated with all sorts of properties, but actually when they mutate, I think they may lose some of them. So it might be kind of silly that I invested so much time in it, but only now I just realized that I could do it. So in the long run, it will be a better thing to do. So in order to get the glacial bee, what I'm going to need is either an icy bee or princess, of course, and a wintry drone or princess. And obviously, since I've got only drones, let's take one of those wintry drones and mutate it together. And before actually setting it up, let's get another star in here so it can assure 100% success rate, or at least hopefully something like that. Let's actually get a few more. Just refuel the nether star storage here. So that's that. And let's drop the icy princess and the wintry drone, and hopefully they'll mutate. And actually, if you're not sure what I just did with another star, it's an old feature that I've added using something called the mutator block, which you can feed it all sorts of resources, another star being the highest tier of resource, supposedly giving you 100% chance to mutate. So this is why I'm using it, and of course, some time ago I've created an auto-crafting system for another star. So the moment I just depleted my entire stock, it will refill up until I think 16 or 17, something around that, and it should be fine. Okay, so the durability of the queen is going down, meaning it's working, no problem. So that's fine. Now another change I want to do, again, all of this while waiting to get my gates. Well, I can't sleep. Okay. Another change I want to do is in the previous episode I've actually added an self-resupply system for hardened glass and for electrum ingots. Now the problem is pretty much this. Because both of them are running on the induction smelter, it's kind of a problem that both of the recipes run on the same machine. I've encountered this before, and you can see what's happening. Items are trying to be pushed where they shouldn't be pushed, and it results in this kind of very odd problem. Now, as a result of that happening, I want to make a couple of changes. So the main change I want to do is pretty much change the recipe of which I'm making electrum ingots. Now, if you look closely at the hardened glass recipe, pretty much there is no other way of making it other than smelting in the induction smelter pulverized lead and pulverized obsidian or ingots. Doesn't matter. It's some sort of obsidian and lead in induction smelter. But on the other hand, electrum ingots actually do have other methods to get them. Main one being is getting electrum blend smelted. And the trick is, instead of what I've been doing so far is actually smelting together in induction furnace silver and gold, because so far it seems to be the simplest. But at the moment, actually getting electrum blend separately by combining pulverized silver and pulverized gold, or smelted, it doesn't matter, into this electrum blend, it's actually a lot easier because I can separate it completely from the entire system. Now the thing is though, I actually need to keep in mind that at the moment, at all times, whenever I get pulverized silver and pulverized gold, I smelt them together in here. So I'm going to do a couple of changes actually. Gold is actually not a big of a problem, but silver might be. Let's see, let's try and figure this, let's try and figure a nice way to get it done. Okay, so here's what I'm going to do. At the moment, through my processing unit, every time that I get either gold or silver, they're processed in the following way. Gold is being directly smelted into gold bars using an induction smelter, which actually give me slightly higher produce because I also get slag. But silver, I directly macerate into silver dust. Now the difference is though, is that Electrum Blend can use the Forge dictionary to differentiate between the different types of dusts. But there is a significant difference between a silver dust and a pulverized silver. Those are products of two different mods. Of course, essentially they're basically the same thing, but since they're products of two different mods, I can actually take advantage of that. So here's what I'm going to do. I'm actually going to change the recipe that creates electrum ingots. I'm going to take that recipe out. And I'm going to get, let's see, I'm going to need some gold. And I'm going to need some silver. And I'm gonna pulverize them. I have the pulverizer right here, which at the moment only has the recipe to pulverize obsidian. The pulverizer has only one output. It receives from the top, outputs into the side, which is a universal output, pretty much a simple auto-crafting recipe. So here's what I'm going to do. I'm actually gonna first get some pulverized silver and pulverized gold. So I have some of those example materials to work with. And I'm going to take them out, of course, out of the actual system. Pulverized gold, pulverized silver. And I'm going to look for, I'm going to need some blank patterns, of course, to create new recipes. And actually can create a few more. And I also, well, I already got the electrum ingot recipe, so I can change that, modify that. Anyway, the electrum ingot recipe is no longer here, it's now going to be changed. So first, let's introduce two new recipes which will know how to create the pulverized dusts, the pulverized materials. So pulverized gold will be a product of one gold ingot. Will give you one pulverized gold. Actually, you know what, I'm just going to overwrite this recipe. Just like this. So this is pulverized gold. And one piece of silver ingot will give you a pulverized silver. So let's quickly dump those into the interface so I know that they are in place. So they are now, the system now knows how to create the pulverized dusts. And when I combine them together, when I take one pulverized gold and one pulverized dust, in a simple auto-crafting recipe, I get electrum blend. So I can take that recipe, dump that into my assembler, and my molecular assembler, and actually ask my system to get me some. So if I ask for electrum blends, I can take one. It will actually craft two. It will go through the process of pulverizing a piece of gold, a piece of silver, and then combining them together. And after all of that, I can take the electrum blend out. And simply, if you smelt one of them in whatever way, you get an electrum ingot. So it doesn't matter how and where. Obviously, I'm going to use my electric furnace, which is a part of my plant logistics system. So what I'm going to do is take one electrum ingot and create a custom recipe. So that you should give me one and one of those. I'm going to blank pattern. Didn't I ask for 10 or something? Ooh, I'm out of glowstone because I used all of it for the nether star. Okay, I need some glowstone first. And on my way to the nether was checking on my alveary, and surprise, surprise, got myself the perfect match right to begin with. So I'm going to take those two out and actually I can try and BLize them just to be sure what type of information they already have, although it doesn't make too much of a difference. Fertility 2, it's fine. I would really, well, I think it's the highest I can get. Their tolerances are quite bad. Yeah, I'm going to inoculate them with all sorts of serums before doing anything with them, so I can get rid of those drones. And let's start by inoculating them with all sorts of good stuff, beginning with fertility. So I want to start, as I just said, start inoculating with good stuff while doing all these other things. So right now, glowstone is what I'm looking for. Okay, so I got a bit more glowstone. Actually, the system remembered my two requests, so I got at the moment 20 of those blank patterns, but I don't think I'm going to need all of them, not now at least. Okay, so very simply going to take the electrum blend recipe, tell that it's a custom recipe, so I'm going to have to set the output myself. Take that recipe and simply dump it into the respective machine. That's a compressor, that's the macerator, so that must be the electric furnace. And realize that this is full. Okay. Since I'm kind of paranoid like that with the way everything works with relays, what I can do is actually should be relatively easy. Yeah, I'm going down the relay for that. If you don't know me, I don't like having like having two of those interfaces with custom recipes right next to each other. I don't know why, I just don't like having that. So let's have that relay facing into this relay, and that one will be a new interface. So another interface right there, and that will be having the new recipe. And now I can craft electrum ingots again. So the system that has been automatically crafting them so far should now resume on the process whenever it can. And it already is doing that. So that's the second thing that I wanted to do. So now those recipes will not overlap every time that I'm trying to craft something. So that's pretty much what I was looking for. Okay, and one more thing before I actually begin with the rest of the automation of the auto crafting of the gates. I actually wanted to add even more cells and more lasers. So I went ahead and created 10 of those energy cells and also soon to be 10 lasers. So that's all of the cells on me, and the actual lasers, 10 of them. They are much easier to create. And I'm going to set them up very similar to what I've been doing here. Hello, Pigman. Since of a limitation that I'm kind of bound by, since I'm using the conduits instead of normal pipes, I'm kind of bound to place them like this, only rows of 2, since of something I would like to do with them in the future. So the way I'm going to set them up will be right here, no, this is still not, will be the final output. This will be the first laser. So those two are just placeholders. Let's remove them, 1 and 2. So those will be the other 10 or the other 8, 9, doesn't matter. Okay, and just place the laser in place. All of those lasers should be interacting without any problem with both assembly tables. I don't see any problem in that happening, but you never know. I'm gonna have to check, but it should be fine. Obviously, I'm also going to need to connect them, so let's get some redstone conduits up and running. And also off-screen, obviously, as you can see, some of those cells have some energy. Off-screen, I've been running my current engine setup to see how it goes, and actually what I was fearing from, I was right. The current supply of water from one ender tank simply is not enough. Like, the ender tank cannot keep up. So I'm going to find a different solution for this. But that should be fine in terms of energy. Now, the process finished. All the process is finished. Now, I don't know, did I get the amount of gate that I was looking for? I think there may have been some errors. Yeah, I was asking for more than 17. But here's something I actually realized that I could try and do. At the moment, each interface has a custom recipe. The custom recipe dumps it into a relay, that relay dumps it into an obsidian pipe, that obsidian pipe goes into the assembly table, and the assembly table goes into a chest, and then it repeats. And then it's imported into the system. I just realized that I think, I might be wrong, but I think all of this can be avoided if I simply replace this, moves this away, move this away, move this away, move this away, and move this away, and simply have the interface directly connected to the assembly table. I think I can actually bypass all that mess and it will still be working, but that's going to require some testing, so I'm just going to do it right now. I will need some cable, I've got some right here. And my theory here is that whenever the interface will try to create a recipe, it will push all the items into the assembly table, and the assembly table, once done, will realize that the interface has an available inventory, so it will export back into the system, and that pretty much solves the entire problem. But then again, I did not test that, so let's just test it right now. So I can craft from here, let's try crafting some red pipe wire. So let's take out all the red pipe wire that I have in the system and try to craft more. And yep, it works. Nice, let's try to craft 68 more, 64 more, so I can actually see it in process. Yep, it dumps the material inside, and then the materials get outputted back into the system. So that's kind of awesome. That's something I actually realized off screen and can solve some problems. I still have to use separate assembly tables for separate recipes, and that's something I don't think I can ever avoid, at least not at the current way of things, but I can also change it right here. So let's also move this interface into right here and have the same thing. Re-implement the recipes. I can get rid of this relay and just reconnect the cable to be connected like this, and it looks a lot cleaner, and actually avoided using some import buses. Now again, still, those assembly tables have no interface with each other, and the interfaces, the ME interfaces, have no interface with each other as well, or the different assembly tables. This is still something still a repeating principle here. Can even make it a little bit more uniform by placing the interface right here, and actually it looks a little bit nicer, I think. So every assembly table has its own interface, and I can kind of expand on it modularly. Okay, now I did get, how many gates did I get? I got 17. That's not even remotely close to enough, so let's ask for more. I might, should I add lower tier gates? Mainly, they're just simply faster to craft, which is the big part of what I'm interested in. Less than, say, cheaper to craft. I don't care about the recipe. I care more about the speed. But if I do that, I'm going to need to make a couple of changes, which is... Oh wait, I might not need to. Okay, you know what? Let's also implement iron gates, iron ore gates and iron end gates. I'm not sure what their limitations are, but until I won't test it, I will not know. So, to create some iron gates, I'm gonna need an iron chipset. And actually, you know what? I can see right here. The assembly table to create an iron end gate requires 40 units of something. I think it's Minecraft joules. And golden gates take 80,000, so there is definitely some difference in the numbers. Yeah, and diamond even more than that. And I guess the most simple gate simply requires half of iron, but I think they're very, very limited in what they can do. So let's go for iron gates. I'm going to add the recipe to create iron chipset, which is iron and redstone. So let's get both redstone and iron. And I'm going to add the recipe to this interface, I think, which requires, this is either redstone and gold. Yep, I'm going to add the recipe to this interface. I think I can add them to both of the interfaces in terms of interacting materials. It should be fine, both of them. If you're not sure what am I even talking about, because of the way assembly tables work and the way I try to automate things, I am actually limited by where I can actually place some of the recipes. I cannot place them wherever I want to place them. So there is a certain limit which I try to abide by, but actually in this specific case I think I can go for either one. So let's create just one of those gates right here. Let's turn on the recipe to tell it to create redstone iron chipsets. We can actually turn on the engines to fill up the other cells as well with energy to make the process even faster. Yeah, it's now significantly faster. Okay, so now the assembly table will remember that I like creating iron chipsets, the redstone iron chipsets. So that's good. So if I take that chipset out of here, the iron one, can create a custom recipe with a blank pattern that will say that if you give me one of this and one of this, I'll give you back an iron chipset. Now that recipe I can simply dump into this interface, and I can now craft iron chipsets by demand. And with those chipsets, what I can do on an assembly table is create iron gates, and I can create either AND gates or OR gates. As far as I'm concerned, I don't think I need... Let's just implement OR gates. Let's implement iron OR gates. I don't think I need both, so there is really no need. This one creates the OR gate, so let's keep it uniform. Let's keep this one making OR gates. So if I give it this and this, let's turn on the recipe to create an iron OR gate. As you can see, all the lasers interface with both tables. So this was the intention of creating this additional set to have even more power by demand. Again, this creates the AND gate, this will create the OR gate, so let's keep it uniform. So when this will output, I'm actually going to need to implement that recipe. Okay, so the gate is finished and automatically dumped into the system. I'm going to take it out of here and tell my system I'm actually going to need one more iron chipset as a result of using the previous one. It's going to take a little bit of a while. Okay, so with that iron chipset, let's combine it. I'm going to do one more blank pattern. With that iron chipset and a piece of red pipe wire, you can create an iron OR gate, make that custom recipe, and set it up. Now actually I'm going to need to test it whether or not does it help me. So this is actually the first glimpse you're about to see on my plan, on how exactly do I plan to automate anything. I'm going to use the cobblestone structure pipes. They are a Buildcraft pipe which basically has no use except for using with gates. They're pretty much designed to be used with gates because they cannot move anything around. So if I place this one here, place the iron OR gate here, can I check for energy can be stored? Right, this is pretty much exactly what I need, so they can be used for whatever I need them to be used for. Let's dump the pattern in here and ask for 19 of them. So iron OR gate, please give me 19 more. Now this is going to be quite a long process of crafting the iron chipsets and all that good stuff. It already dumped all the red pipe wire into here, and now it will go through the trouble of actually crafting all the iron chipsets first and then dumping them into here to create the actual gates. So there will be some, it will still be a long process, even though I have so many lasers, it's still a long process. Okay, they're kind of gonna bounce back in between. Okay, so let's start setting up the actual, the rest of everything. So for this, I'm gonna need a bunch of cobblestone structure pipes, a bunch of them. Actually, I should probably turn this off. Okay, still, the engine can still run, but the moment they're gonna reach a critical point, which they actually generate too much heat, the amount of water distributed in between them will simply not be enough. So I should actually know what, I'm gonna turn it off right now. I don't want them to accidentally explode when I'm not paying attention. So let's get a bunch more cobblestone structure pipes. They're simply normal cobblestone transport pipes combined with gravel. Simple as that. Nothing about it. So, be right back. Okay, so I only have 20 lasers and as a result 20 redstone cells, but I'm actually going to create a lot more pipes. I'm going to create... I think I'm actually going to go for a full stack. I might even need a little bit more. But yeah, I'm going to go for a lot of those pipes. So let's go for a full stack to begin with. We'll see if anything needs to be changed later on. So basically, every cell is going to have its own cobblestone structure pipe. Now, the entire limitation of why am I doing them like this, why am I doing them in those arrays of 2 by 5 instead of setting them up, for example, like 5 by 4, you may be asking yourself. And the reason is very simple. Since I'm using redstone energy conduits, you cannot place buildcraft gates on them. Otherwise, if I hadn't used them, I may have just used the normal buildcraft conductive pipes, and you can place the gates on them, but you cannot place gates on those things. So this is why I'm limited by the size, because this way I can interact with every face of the entire structure just from one side. If I had, for example, another row of redstone cells in the middle, I couldn't interface with them any way whatsoever. There is the laser on front, there will be the conduits on the bottom, and each side will have a cell. So this is the only way I can interface with all the different cells all in the same line. This is kind of made on purpose this way. So everything said and done, let's place all the cobblestone structure pipes. And I'm going to need all of them to be connected together to each other. So let's find a nice way to get it. Let's just connect it here and also kind of go up here, so it's all kind of symmetric and nice looking. There is this visual connection to those conduits, although it makes no difference whatsoever, really. I'm going to need some of the red pipe wire, and I'm going to have a red pipe wire on every every pipe. And if you're not familiar with those pipe wires on what they do, you're about to, or maybe not in this episode. I don't know how much time I've left, but not a lot, so I might not finish it today. But they're pretty much a way to traverse signals other than just redstone on pipes. And Buildcraft by default give you 4 of those different versions. So if you go to pipe wire, you got 4 different colors. Now the difference between them, the only difference between them is which gates can interface with what. So golden gates can interface with both red pipe wire and blue pipe wire, but they cannot interface with green and yellow. So if you need 3 separate signals or more, or 4, you're gonna need to have to use diamond gates. You cannot use golden gates. And iron gates can only interface with one color, which is the red. Red is the simplest color, blue is kind of the second complexity, you may call it, and green and yellow on the same level of complexity, being in the last level of complexity. So how many gates do I have so far? I already got 5 gates, okay. So the plan is, at the moment, 5 gates will give me only 5 cells, but every cell will need to have its own gate. This is why I automated this process and added so many lasers to make this a lot faster, because I'm going to make a lot of those gates. So every cell will have its own gate. And the logic here will be every gate will check its own adjacent cell. This is simply the way it works. And the logic I'm going for is if there can still be stored energy, if you can still store some energy in that adjacent cell, emit a red signal. As you can see now, the red pipe wire changes color, and you can also see the gate is turned on. That basically means it's true. If I change the rule, for example, now it's checking if there is no energy. Obviously, since there is some energy, the rule is now false, and there is no signal in the red line. So energy stored is nice. The rule I'm checking is whether you can still store energy. And I'm going to apply the same rule. Can I still store energy? And the same result. Turn on the red pipe signal. And you can probably already understand what I'm going for here. I'm going to check for the same rule, every rule, all the rules for all the cells. And since it's one unified line, which basically checks whether true or false, and enough for one of those signals to be true, and the entire line basically means it's true, like the entire signal means true, that will be the check, one of the checks for turning on the engines. So you can pretty much understand what I'm aiming for here. So since all of them, again, all of them will have the same check when I have enough gates, and all of them will check for the same condition. Enough of one of them to say, yes, I'm going to need energy, and the entire line is going to be turned on, and then the energy will be distributed. Now, by design, since redstone energy conduits distribute energy the way they do, kind of evenly in between all cells, this will also make sure that no energy is being wasted, and the moment that none of those cells request for energy, it will be turned off, because this will be the condition that will be turning off. Again, very simple, just requires some implementation, and it might be a little bit pricey and time consuming because you're going to need a gate for every cell that you're checking. Now, obviously there could be some changes made. For example, if I didn't use a cell per laser, for example, if I used let's say one cell per array of lasers, and they will be connected using conduits directly from the cell, then I would need only one gate for that cell. But simply the way I designed it, the way I want to go for it, this is the way it's going to end up. I think it looks nicer, and I kind of like having everything large scale. Like every laser has its own cell. It's like very crazy looking. Simply like the way it designed. Okay, so looking at the episode length, I will probably not be able to finish the entire design today or now. There is still some overhauling required for these engines. I'm still considering on a way to do it. I may just change my design to require pretty much a lot less than I'd intended. But we'll see. I might not. I really need to see it through, check it out, see how it ends up. Either way, I'm gonna pretty much go ahead and off-screen wait for all the gates to finish, and also try and get my bees fully mutated to my satisfaction, so I can start using those glacial bees and create more crushed ice faster, because I really would like to replace water with crushed ice, as it's more efficient. I don't know if actually crushed ice will be able to sustain all those engines, because water sure can't, but at least I would like to try, see if it really works or not. Alright, as always, thank you guys for watching, and I'll see you guys next time. Quick note, if you're still watching, I just realized I had a mistake here. My export bus wasn't set to be active only with signal, and I didn't understand why am I creating so much hardened glass, which I have almost 500 now. But again, that will last for a little bit longer, and now I've just changed it to be active only with signal.